Now, the next concept we are going to discuss about maps in Golang. So let me. So what do you know about the generally maps concept? There are certain things you need to know. I hope I am audible. Please confirm. There are, yeah, sure. So thanks. There are certain things that we need to know about maps. Generally, we call them as hash maps. Maps work on a concept called hash table. Okay. Before going to talk about hash table, you should know actually the concept of hashing basically. If you don't know hashing, then you don't understand why maps work efficiently. Okay. Why do you use maps? Why can't you use your own data structure generally? The reason is maps are very efficient data type, efficient structure or efficient type. Almost in all occasions, almost, not in all, almost maps can be retried with constant times. Constant times means if you go for big O of notation, big O of 1. In some cases, wherever there are collisions and then there are some overflow bucket, there are buckets chaining of data and all, it may go for, in some cases, big O of n. But most of the cases, it is big O of 1. Constant times means it exactly goes where the value is stored and pick it. Okay, if you write two loops, then we call it as n square. Okay, you are using a loop and inside that you are writing some other logic with a loop, may not be completely iteration of the loop, maybe n log n, n log 2, something like that. There are certain things. So maps are efficient to retry the value. Fine. Maps contain keys and values. So values are mapped to the keys generally. Fine. A value is mapped to key or values are mapped to the key. This is a basic concept. Before going to understand this, how values are mapped to the key, you must know one thing that is called actually hash function. Because basically maps work on hashing algorithm. Okay. So you should know actually what the hash function is. What hashing does. What hashing does. Let's say I create a file. For example, I create a file. The name of the file is hello1.txt. Hello world. I give. I create a file. The name of the file is hello1.txt. So I put it as hello world. I create another file hello2.txt and I write hello world. So I have two files. One is hello1.txt and the other one is hello2.txt, which has got a uh, content, which has some content which is called hello world. Here there is hello world and then here also there is hello world. If you when you apply a hashing algorithm on these files, when you apply a hashing algorithm on this file, generally you get a SHA. SHA is nothing but secured hashing algorithm. You get a hash. You got a hashing value. For example, there are some libraries to get the SHA. There are some libraries to get the SHA. Even in Golang, you can get the SHA of a particular thing. Let's use a library SHA SHA1 of hello1.txt. This got to be the SHA. This is the SHA1 of hello1.txt. When I apply SHA2 on hello2, SHA1 on hello2.txt, you get the SHA for hello2.txt. Let me apply SHA1 once again. This got to be the SHA1. Let me go here. Let me delete everything. SHA1. SHA1 is an algorithm. There are a lot of SHA algorithms, SHA-256 like that. SHA1 is one of the algorithm. This is called SHA1 of hello.txt. So if you really notice the secured hashing algorithm, one, SHA1, on two files, you know, the SHA is same. You see that the SHA is same. Why does the SHA, why the SHA is same? Why is the SHA same? The concept is because the contents in the file of both the files h1 and h2 is same, and hence the SHA is same. That means secure hashing algorithm always generated based on the content. Secured hashing algorithm is generated always based on the content. As long as the content is same, the SHA is same. It's one of the reasons actually, if you look at the any source code management systems other than Git, the old source code management systems, something like Harvest or Visual Source Safe or Team Foundation Server, these source code management systems, whenever you create a branch, whole files used to be created inside the branch, as far as I remember. It's been years I used, but whenever you create a new branch, you get whole bunch of files along with the branch. That means I have 10 branches, 1,000 files are there in my project. 10 branches you get 1,000 copies of all the files, whether the files got changed or not changed. But if you look at the Git, the concept is different. Git doesn't create 10 branches, each branch 1,000 files, doesn't create 10,000 files. Git is very clever enough to understand what files got changed, and then it maintains only the changed copies of the files in for each branch for each branch. It's not going to create actually 1,000 files for all the branches, 10 branches, 10 into 1,000, 10,000 files. Rather, Git works very intelligently, understanding that what files got changed for a branch, and then it changes those files. It's not going to change all the files. It maintains only the copy of the files which got changed. How does it know whether the file is changed or not? The simple thing is it can maintain the SHA. Let's say I go to hello.2.txt. I put a space. I just put a space, nothing else. I just put a space and I save the file. I go and then applied the secure hashing algorithm. You see that the the SHA secure hashing algorithm got changed from this file to this file. It's changed. It's changed from this file to this file. Why it is changed from this file to this file? Because the content of the file got changed. The answer is very simple. The content of the file got changed. That's where the shy is. For example, a cyber security, let's say that okay, police has got a video file or an audio file, which is for 2 hours, for example. They want to check, they got another version of the file, so which is another 2 hours. They don't need to go and listen those 2 hours and 2 hours, 4 hours to know that both the files are same or not. Someone says that no, it got tampered. Okay, uh, they can say anything. I mean, then they don't need to go and see both the files. They don't need to go and see both the files, listen to both the files. Rather, they can just apply secured hashing algorithm on both the files. If the SHA is same, it's a cryptographic library. If the SHA is same, basically the files are same. If the SHA is different, their files are different. There is some difference in the file. What difference is a different thing. It could be time, or it could be size, or it could be the content. But time means the duration of the audio file, I mean to say. But the files are different. Pretty simple, right? They don't need to go and then listen whole files and say, they can simply say that, yeah, both of them are different. Both of them are entirely different. That's where actually the SHA comes into the picture. Okay, that's what the secured hashing algorithm work. Why I am talking about secured hashing algorithm is actually this is what hash. Okay, uh, hashing is this. This is called the hash. SHA means applying the hash on a file or on some content, which we call it as secured hashing algorithm. How SHA matters or hashing matters for a map. Map contains keys and values. As long as the key is same, okay, and you cannot create a new key with a duplicate key. You cannot create a new pair with a duplicate key. As long as the key is same, the values gets updated. If you change something, the value gets updated on the particular key. So generally, how it works in Go language, this is a about SHA. We are coming to the hash table. When a map is created, how do you create a map in Go language? This is what where map one or my map is map of key and value. Let's say the key is string and the value is any. That means technically I can create any value. I can create any value. Key is string and the value is any. Okay, I can create any value over here as the value. So there is a key and there is a value. As long as the key is same, the values are mapped to the same key. It gets updated or it gets appended if it's a slice under whatever it is. And the question here is there are something, okay, keys and values or pairs. That's first thing. That means keys values are mapped to the keys. Okay, that is means values are mapped to the keys. Second thing, what could be the key? What data type can be the key? Any data type that on which you can apply comparison operator, particularly the equal to operator, that could be the key. Any type on which one can apply comparison, basically equal to operator, can be the key. What does it mean? For example, let's say str1 and str2 equal to hello is one, and then world is another one. Can you check if str1 equal to str2? If you can check this, if this can be checked, str and str2 are string, then the string can be a key. If you cannot check this on any data type, that cannot be the key. This is the key and this is the value. That's a rule. Okay, let's say slice 1 equal to int of 10, 20, 30. I have got slice 2 int of again 10, 20, 30. I want to check if slice 1 equal to slice 2. You see that I cannot check this equal to operator directly on a slice. Invalid operation. Slice can only be compared to a nil. You cannot go and then say slice 1 equal to slice 2. You want to use this, there is a separate function in I think slices library. Slices might be dot equal. You have to use slice 1 comma slice 2. It, it gives some value. It gives whether slice 1 and slice 2 are equal, but you cannot apply equal to operator on slice 1 and slice 2. So the slice cannot be the key, as simple as it is. A slice cannot be the key. Any can be the any if any you can check. You understand the concept. I hope you understand the concept. But here you can't do that because equal to operator. So you can use the data types on which you can use equal to operator. Okay, here both strings are same. Just telling you that how can you apply equal to operator. Here cannot use equal to operator, but you have to use an equal function. So you cannot create a map with with the slice as the key where my map to as map of integer and then maybe any. This doesn't work out because the slice cannot, you cannot apply comparison operator on a slice. So you cannot go and then use a slice as a key for a map. Okay, you cannot use a slice as a key for the map. Fine. What data type can be a key? Any type on which you can apply equal to comparison operator, that can be a key. As simple as it is. Okay, fine. Basically, when you create a map, what happens when you create a map? When a map is created, based on the number of elements inside the map, okay, based on the number of elements inside the map, some buckets are created. We call it as a bucket. Okay, generally based on the size of the map, that means how many elements you're gonna give to the map. Based on the size, buckets are created. Generally, it is hidden how many buckets are created, but I think it starts with one bucket. So what happened? Each bucket has got each bucket means each bucket is an array. Each bucket has basically keys and values. What does each bucket contains? Each bucket contains keys and values, generally parallel arrays. That means each bucket has got internal structure that, something contains keys and something contains values. That means it has got, let's say, if you look at a bucket like this, let me create this way, something like this. Assume that this is a bucket. This is a bucket. Assume that this is a bucket. There are two areas inside a bucket. One is called the key. Actually, bucket has got its own structure. I'm just showing you something in a visual representation, but bucket has got the same structure, different structure. And each bucket contains 8 keys and 8 values. A bucket can store 8 keys and then 8 values. Okay, 8 keys and 8 values. Let's say, assume that this is key, 8 values. So this is maybe 0, this is 1, this could be 2, 3, 4, 5, 6, and 7. That means, see, these are the actually index, it's a key, and these are values. Bucket contains these details. These are keys and these are values. You can understand these are the index. This is a bucket. Like this, few buckets are created. Like this, few buckets are created. Assume that this is the first bucket, but like this, there are few buckets created based on the load factor. Actually, load factor means number of elements by the number of elements by the number of buckets. There is a concept called load factor. How many buckets are created? How many buckets are created? It's based on the load factor. Load factor means number of elements divided by buckets. Then you get some number. If the number is less than 6.5, it reaches, let's say I have 15 elements and then I have two buckets. The load factor is 7.5. Okay, uh, which is more than, if it is more than 6.5. Okay, then what happens? 7.5 is more than, let's say I have 14 elements and then two buckets. Let's say if there are 14 elements, that means element means key pairs, key value pairs, and two buckets. The load factor is 7.0. So whenever the load factor whenever the load factor goes beyond 6.5, then the number of buckets are doubled. The concept is same, similar to slice. Remember that slices, the number of slices are not always doubled. Up to some range, it gets doubled. The algorithm got changed. After some time, I think it increases only 25% or something. For example, you have 1 million elements in a slice. You want to add the 1 million plus first element. If it goes beyond the capacity of one elements, 1 million elements, then it would not double. It increases only 25% of the one-fourth of the total. When you are talking about a scale of 1 million elements, if you're talking about a scale of 10 elements, 20 elements and all, it doubles. 10 becomes 20, 20 becomes 40, 40 becomes 80, 80 becomes 160, etc. up to some limit. Exactly, I'm not aware of the number. I think 1024, I guess, but it depends on internal algorithm again. So, number one, when you create a map, buckets are created, one or two buckets. It's Go doesn't tell how many buckets. Each bucket contains generally 8 elements. Each bucket contains 8 elements. That's very, very important. Okay. And then what is the hashing here? What about the hashing here? This is a very important part of it. The bucket contains two arrays. Okay, eight elements. That means 8 elements, 8 keys and values can be stored inside the bucket, basically. When you when you try to create a key to a value, okay, let's say how do you create? These are just for your understanding. These things are not exactly nothing to do with the array, a slice, sorry, map. Just want to tell you that what is an equal to operator. How do you enter some elements? This is only the declaration, only declaration, but not instantiation. Here actually the map is nil. A map can be nil. Okay, in fact, a map, if you go for a map can be nil if not instantiated. That means here the map is nil basically. This is a nil map. You can check if my map equal to nil, then fmt.println, nil map. The map is nil over here, nil map. Why it is a nil map? Because you have not instantiated. How do you instantiate a map? My map equal to make of the map. You can see that you can say make of the map. If you want, you can give the size of the map if you really know the size of the map, or you can anticipate some size. You can give the size of the map. An empty map is allocated with enough space to hold the specific number of arguments. Enough space means some buckets could be one bucket or two bucket. It's not very clear in the documentation. I think it got changed. Earlier, it used to create I think eight buckets with each bucket contains 8 elements. Later on, once it became 16, these are all actually as far I remember, but exactly may not be 100% true. But however, 8 buckets was what actually I understand, but I remember. But later on, they changed the implementation of a map. They say that a small starting size is allocated. So number of buckets are depends on what is the size. I am not giving any size over here, but I would like to give the size. The size would be automatically given as and when elements are added to the map. Let's say, how do you add elements to the map? Now map is instantiated. How do you add elements to the map? My map of key, maybe let's say 560086. Value, I give it as Bangalore 1. Maybe I give 96. Bangalore 2. Maybe something called 34. Bangalore 3. Like that, I can give a number of keys and values. Here you can see that the key and value, the here if you can see that uh, the value could be of the value could be of uh, uh, the value could be of anything because we gave it as any. Okay. Most important thing is the value we gave it as any, so the value can be of anything. Value not necessarily to be the, in this case, I'm talking only in this case, not necessarily to be the value can not necessarily to be the string, anything. Yeah, no, no, no. Make is I thought make you can do, but make is a built-in construct that gives you some size to the map. I'll tell you how you can create without make as well. Okay, I'll show you. Let's say one more thing. 695011 is this is the key and the value is Trivandrum Medical College pin code. Okay, you want to create without make. Make is to instantiate the map. Make is used to instantiate the map. Make is used for three things basically. Make and it is used for the slice, map, and channel. Slice we already saw. Without make also we have created slice. If you really observe it, without make also we created slice by directly assigning values to the slice. Similarly, we can also create a map without make as well. Let's say I create a map where my map 2 is map of string and then maybe string. Keys and values are string and string equal to I can directly assign values like this without make. Let's say I give 560086 could be Bangalore 1, Bangalore 1. Another key is 560096 is Bangalore 2, etc. I can give this is also a map which we didn't use make. This is directly assigned. This could be this also you can use, but this usually we don't use. Very rarely people use this syntax. It depends on, but without make also you can do. Similarly, for example, you create a slice. How do you create a slice? Slice one equal to this is a normal way make of in sorry uh, integer comma 10 for example. You can also create a slice 2 equal to integer of okay 1 2 3 4 5 6 7 8 9 10. So both of them are creating slice only. So but make is very regularly used because make your see if you don't use make also internally it uses make because make is an allocator. Where does it allocate? It allocates either in stack memory or heap memory. In Go we cannot say whether it's going to be, we can anticipate but we cannot 100% say. It's because the because the uh, co-compiler decide whether to store the value in a stack memory or heap memory. We discussed about it earlier. So this is one way to create a slice, and this is other way you create a slice. You don't have the values upfront generally. You create the first way. So most of the folks, most 90%, we use the first approach. Similarly, even for the map, 90% we use the first approach using make built-in function. Make is a built-in function. Make tells that you can decide the capacity or the size while using make. You anticipate, because why do you need capacity? What is the use of a capacity? If you really look at it, what is the use of a capacity? Capacity algorithm or size algorithm is very efficient, so that you are anticipating some a number of elements inside your slice or a map. You are little bit clear about how many elements are going to be stored inside your map. Okay. uh, so it's pretty good actually. You are allocating sufficient memory upfront. That's why the capacity algorithm works always in most of the situations. So better to go for a capacity algorithm. Fine. Coming back to the concept here, I said that there is a bucket. There is a structure for the map. Okay. Now, how does it know that which bucket it has to go? The buckets are taken. How does it know that it goes to which bucket? Generally, what happened is there is something called hash function. Hash function is it takes the key. Okay, it takes the key. Let's say that this is the key. For example, this is the key. The algorithm is little different, but I'm just explaining. We have basically we have the buckets, and then each bucket has got a separate array, two arrays, basically parallel arrays. Each bucket has got the parallel array. The parallel arrays are going to store keys and values. That means inside a bucket, one array is for the key and the other one array is for the value, but index of 0 is taken, but in the index of 0, it stores both the key and value of the same pair. Okay. Generally, what happened is if a key is formed, hash function, what is the importance of hash function is it basically whenever it is performing a hash function, it knows that how many buckets are available inside the system, how many buckets are available inside the system, inside the map. Assume that there are four buckets. Assume there are four buckets. There are two buckets, two are full, then it doubles the number of buckets, then the buckets have become four. It takes the key and it applies hash function, hashing algorithm, like SHA, what we have done with the SHA, it applies the SHA hashing algorithm. The SHA, this algorithm, assume that it is split it into two parts. One we call it as a segment, and other one you can call it as a offset. Let's say the whole algorithm, the whole SHA is split it into two parts. One is called the segment and the other one is called the offset. Basically, the hash function, the concept may be little different for different programming languages, but generally the hash function is what important is. Hash function is going to give you two things. Number one is the number of bucket number, in which bucket it has to store the value. How does it give the bucket number? The bucket number is always evaluated based on the buckets available. Let's say that there are four buckets. The bucket number is always from 0 to 3. Any number. It applies some mathematical equation, maybe modulus, modulo operator and all, and it gives you some number. The number is between, that means number should not exceed more than 4 because there are only 4 buckets. It should not go even 4 because 0 to 3 is the index. It takes 0 to 1, 0 to 3. And the second thing is the index inside the bucket. So the segment and offset. the segment and offset. The first one gives the uh, number of bucket and the second one gives the index inside the bucket. Let us say bucket number 2, index number 4. Bucket number 3 is 2 is the third bucket. Bucket number 2 is what actually? Bucket number 2 is the third bucket. We have got a bucket like this. I cannot give here. Assume that this is bucket 1, bucket 0, bucket 1, bucket 2. Let's say it gives the third bucket. 2 is the number. It goes to the third bucket 0, 1, 2, and it gives the index as 4, for example. This is the fourth index. Here it stores the key and here it stores the value. Okay, got my point. Here the key and index of the bucket, and then number of bucket, the bucket number, and the element inside the index inside the bucket array. So it directly goes and gives uh, store the value in the exactly that bucket. So as long as the key is same, the number of bucket that it gives is same, the index it gives is same, because the key is not going to be changed. That is what the hashing is important. You know that as long as the data inside the hash is same, okay, always it gives the same value, same hashing. This is the unique thing, right? There is a chance that there could be a collision occurs. When does the collision occur? Two different keys produce the same hash value and they are mapped to the same bucket in the table. Okay, same bucket, if at all, same index it gives ultimately. The same key means actually same hash value, two different would never generate. But what if two different elements, two other element also gives the same bucket number, not the key. The hash is different, definitely same bucket number and same index. Then the collision happens. You know that each bucket can store multiple keys and value pairs. This is what? If multiple keys hash to the same bucket index and the value, then that gets stored in by using a linked list. That means there is a linked list. That means it's not only the bucket not only contains the keys and values, but also a linked list. That means an address to the other underlining bucket. There is a linked list. I'm just showing you in the graphical representation, but it's all the structure actually. Okay, it creates a kind of a linked list. Why it is a linked list? What is the use of a linked list? Linked list can attach in another bucket, another element to the existing bucket, because this particular index inside a bucket 0, this particular index has got two elements. Generally, it doesn't happen. Go tries its best not to ensure the collision happens, because for every index you have a linked list, then it is not going to achieve the constant big O of O. It may go to, where is it? Where did I write? It may go beyond big O of O. So here it may not be always constant. It may go for n. N is what? The number of linked lists, because it has to go to here and search for the linked list. Linked list means you know what is a linked list. Linked list means it can have any number of links internally. It can attach any number of things. So it goes to the linked list. So the moment it goes to the linked list, that the efficiency of the map is compromised. because it's not constant of 1, it would go constant of n based on number of linked list. Okay, so it does not to happen, the collision not to happen. Okay, if the collision happens, when does the collision happens? When the hash generate same hash is generated, hash values, remember that, not the hash values are generated for the for more than one key, a collision happens. So when the collision happens, a linked list is created and attached to the bucket. This is a bucket and this is the values inside the bucket. A linked list is created and attached to that particular bucket. This is what collision happens. Sometimes there is something called overflow. Let's say each bucket has got how many elements? Each bucket has got 8 elements. What if the bucket goes overflown? The number of elements inside the bucket is more than 8. All the slots inside the bucket are filled. Then it has to create overflow buckets because each bucket has got some fixed number of elements to store keys and values. If more, what happens if more keys, I'm not talking about the more keys are mapped to the same bucket. More keys are mapped to the same bucket. I'm not talking about the index, I'm talking about the bucket. Then the overflow bucket is created. Overflow bucket is also something like a linked list. It doesn't encourage it to create more and more overflow buckets because the more overflow buckets are created, it decreases the performance of your application definitely and all. Whenever it happens, the overflow or collision is overflow are two different things. Collision overflow talks about the elements are going into the same bucket. Collision happens when the keys and values are redirected, asked to store in the same bucket with the same index. We call it as a collision. Then what generally Go does, it resize the buckets. It dynamically resize the map, and then it reduces the overflow and reassign the keys and values evenly. It tries to distribute the data across multiple buckets. Okay, that means the bucket number may be 2, it become 4, 4 it become 8, and then it redistributes the values because if the number of buckets are more, generally what happen, the number that it has to return, the bucket number is always less than the number of buckets. If there are 2 buckets, then the number is 0 or 1. If there are 4 buckets, the bucket number from 0 to 4, because the hash function is very intelligent enough to perform that operation. What is the problem with the collision and overflow? Collision and overflow generally it increase the lookup time. Lookup time means to fetch the value from the bucket. Okay, so whenever it reaches the load factor, go goes and creates the number of buckets. That's what it does. Wait a minute. Okay, that's how actually the buckets and hashing and all the algorithm works. Fine. Let's go to the example. Uh, I'm just keeping this aside right now. So how do you access elements inside a map? Now you have assigned keys and values to the map. This is a key and then this is the value. In fact, the key and value, my map of, for example, I give 69 uh, 5012, for example. It's, you can also give a value maybe 2. It doesn't make any sense here. What is 2? But since it is any, this is any, you can give any value as the value. That's as simple as it is. You can give any value as the value. Fine. How do you access elements from the map? We have a range loop. For range loop generally gives index and then index and value, but for map the range loop gives key and value, key and then value, range of my map. So range loop on a map always returns key and value. Okay, range loop on a normal data structure, it returns no, like array, slice, and etc. It gives index and value. These two are key and value are variables. You know that you can create them with any name, any valid identifier. That's fine. But I just gave it as key or value. Some people give it as just k and v. You can also give k and v, key and value. Okay, you can iterate through that key and value. You can iterate through that uh, uh, key and value. So uh, key comma value, just print. Let's say I want to give key value. You can, and the map is not ordered. Remember that the map is not ordered. That means the way how you are going to fetch the elements from the map are not inside in within an order. Whenever you try to fetch elements from the map, they are not in the order. Maps are not ordered. Let's say I run it multiple times. You see that the 2 has come first, and it's not. Bangalore has come first. Maps are not ordered, and map is not ordered. Map is not ordered. Let's see if I go to the sixth point. Map is not ordered, and also by default map is not thread safe. Here map is not thread safe. That means multiple threads, multiple go routines. In fact, it's a go routine. There is a chance of race conditions. If multiple go routines try to access the map, there is a chance of race conditions. We'll see that later on. Fine. You see that how to create the map and then how to assign elements and how to fetch elements from the map. Let's go to once again run it. Let's go to the next example. I instantiated a map directly with a shorthand declaration and then I assigned all the values to the map. I want to fetch the value from the map. Instead of using for loop, you can also fetch the value from the map. That means I can directly go and then let's say value my map of key is let's say 560086. So I can get the value from the map. It's going to print the value of the map. What if the value is not available in the map? There is no problem here because it gives an empty string. Okay. What if there is no value in the map? So here generally we use the same construct that we have been using earlier. What was the construct that we have used earlier? The construct is very simple. Let's say my map of maybe 690013. I don't have the key like this. You know that because I never gave. Still, I want to get the key. So you get a value, comma, there is a construct called OK from the map. You give a value and then you get the second return type is OK. Wherever there is the second return type, even from the type assertion or even from the map, even from the later on we will see from the channel as well. The second OK is a Boolean value. It tells if it is true, there is a value. If doesn't true, it's not true. That means if it is false, then there is no key. That means if true, I print V, else print line no key and value pair. OK is very important. No key and value pair. If there is a key, you get a value, otherwise you get no key and value pair. Let's say if I give 1, 2, no key and value pair, 9695012, if I give, you get some value because I use fmt dot print line. You get some key, sorry. I get the value called 2. If there is no key, it tells that there is no key because the second parameter always talks about whether there is a key or not. So whether the key existed or not, you are going to update to the existing key or you are going to insert to the existing key and all. You can always use this construct and then you can find out. Okay, you can always use this construct to find out whether key and values are existed or not. That's how you can work with the map. That's all for now. You have any questions and all, please do ask. Otherwise, I'll give you a task. Basically, I'll give you a task. The task is maps duplicate count on slice.empty. You take a slice of 100 size, 100 length. Fill the slice with using random numbers, and then using map find out duplicate elements in the slice. Each duplicate, how many duplicate elements are there to be found? Example, I have a slice 10, 20, 30, 40, 10, 4, okay, 30, 8, 20, 3, 4, 96, 45, for example. If you look at it, how many duplicate tens are there? One, two, two tens are there. That means I want 10 as 2. Let's say 20, 20 as 1, 2, 30 as 1, 2, 40 as I think 1, 4 as 2, etc. How many duplicates are there? How many times the number is there basically? You have to find out. So this would become the key and this number of items would become the value. Based on that, you have to find the keys and values and find the number of duplicate elements from the map. That's what exactly I want by using maps. Okay, to summarize, I hope you understand uh, how the maps are, how the maps work, how to store elements in the map. Okay, how the map work. What about the collision? What about the overflow? What about the hashing basically? How many buckets are created? What are buckets? What does a bucket contain? Unlike slice, map doesn't contain any header information like the capacity, the pointer and all. Map maintains an internal structure, runtime.hmap or something. It maintains an internal structure. Map use linked list for the collisions as well as for the overflows. Overflow talks about the bucket. Collision talks about the index inside the bucket. Okay. There is something called load factor. Load factor means if the number of elements are going beyond the buckets, number of elements by buckets. For example, there are 10 elements and then there are two buckets, then the load factor is 5. There are 15 elements, there are two buckets, then the load factor is 7.5. You understand? If the load factor goes beyond 6.5, the number of buckets are doubled and then it redistributes all the elements. Okay, it doesn't redistribute, is redistributing is very important. Okay, so if you really know the number of elements that are coming into the map, it is always good to give the size. You know, at least assume the size and give the size. The reason is if the size is given, the number of buckets are also created in such a way that maybe based on the number of buckets. Size is kind of a idea that you are giving to the map. Even without giving size, map can create buckets. But if you give size, what happens? The reallocations will be decreased. It doesn't go on then reallocate every time. The number of reallocations will be bring or brought down. Okay. This is what about uh, the map. Okay. Thank you very much.